Good morning, class.
Good morning, everyone.
I'm Inge.
I'm Miss Ayu.
Today we will learn about
Lab apparatus. Okay, so today we will show you the apparatus that we usually use in physics lab. And as you can see here, that this is the sets, and we will show you the apparatus one by one and explain its function.
So, we have several measuring apparatus. This is thermometer. Thermometer is used to measure temperature. For this one, it's a thermometer to measure the liquid. You can measure the water or other kind of solution by using this thermometer. When you want to use this thermometer, it will be better if you hang the thermometer. Yeah, put it into the stative and clamp. Okay, and then put the beaker with the liquid inside it. The thermometer reach the liquid only, not the beaker. So the temperature can be read by reading this scale. Just read the scale and then you will know the temperature of the liquid. Okay. Continue. We have a measuring cylinder. A measuring cylinder is used to measure a volume of a liquid. Okay, if I have this liquid, this measuring cylinder, I pour the beaker with the liquid into the measuring cylinder, so I can know how many volume. I can know the volume of the liquid that has been transferred by seeing the bottom part, since it is water. But if it is a mercury, you will read the upper part. Yeah, so you have concave meniscus and convex meniscus. That is why you have to see first what kind of liquid that you want to measure. Is it the one with convex meniscus or concave meniscus? For water, read the bottom part. For mercury, read the upper part. A plastic measuring cylinder, but if you have to work with glass measuring cylinder, you have to be careful, just the same as the glass beaker, because it can break. Stopwatch. This is a digital stopwatch. You can use the stopwatch to measure the time. You can know whether it is getting faster or getting slower. Besides measuring cylinder, I also have a burette. A burette is almost the same as measuring cylinder. It can be used to measure volume. You can see the volume here. But the difference is, the burette, it's not only to be used for measuring volume, it can also take out the volume of certain liquid that you want to take. Sometimes you will work by using this triple beam balance. Why the name is triple beam balance? Because we have triple arm. The one for 100 gram maximum, the one for 500 gram maximum, and the one with 10 gram maximum. So all you have to do when you use this, you just add up. Just add up. For example, let's say I want to measure this cube of wood. This cube of wood. First, before you work, make sure that it is already balanced. It's in zero balance. Okay, then put the cube. You can see that it is raising, right? So it means this part is heavier than that one. So all you have to do, just balancing. It's going down. So it means it's too heavy. So it should be going that way. Until you will find that it is in balance, reaching zero. you have to be patient in using this because it's not a digital one. You have to be patient. Make sure that it is completely balanced and it is completely zero. It is always better if you work with the triple beam balance without any wind. Why? Because sometimes the wind can also impact your measuring. So make sure that there's no wind around you. I think this is it. See, after you balance and it's already zero, you can read the scale. Okay, for this, the scale will be 3.3 gram. So the mass of this wood block is 3.3 gram. Have a vernier caliper. A vernier caliper, it's better be used rather than a ruler. It can measure accurately. You can see here that you have until 0.01 millimeter. But for this one, you only have 0.1 centimeter. So if you want to measure something more accurate, use this vernier caliper. Okay. You can also measure an inner or outer diameter. For example, this beaker. If I want to find the inner diameter, what I can do here, I can use this. Okay, the inner diameter. But if I want to find the outer diameter, I can use that one. Perhaps a ring, you have an inner and outer diameter. Okay, this would be the inner diameter. Something inside it, and you can see it is already locked, right? Because it's not going down, because it is locked. Make sure if you want to use the vernier caliper, it should be locked. Okay, and then for the outer, I use this one for the outer diameter. Here you have this, so you can know the depth. Okay, if I want to know the depth of this one, I can use this. Okay, I slide, okay, until the depth. Then, okay, the depth. So I can know the depth of this one, which of course you cannot measure by using this one, but by using this vernier caliper, you can find the depth, inner and outer diameter. For now, I want to know the length of this one. Keep the block set. It means no movement. So just keep it that way. Maybe I have to lock it so it will not move, and then I read it. From this, I can know that the length of this wooden block is 1.96. Since the 6 is making a line to the line which is up there. So the line from the upper part and the bottom part should coincident meet, and that is the scale of the reading. If I want to make 5% salt solution, it means I will need 5% of salt and 95% of water, which is commonly used solvent. If I want to make 100 gram, means I will need 5 gram of salt and 95 gram of water. Okay, I've already set 5 gram for the triple beam balance, and I've already prepared a paper here. Why do I need the paper? First, so it will not make any mess. And sometimes, if you work with chemicals, chemicals can react with the tray of the triple beam balance, with this tray. So it will affect your result. So it will be better if you just use paper which is not reacted to any chemical, or maybe all you have to do is just put the beaker here. Just put the beaker and then measure 5 gram, or you can do just like that. Sometimes, if you don't want to use the beaker and you want to use this Erlenmeyer, it's also fine. This Erlenmeyer is more handy compared the beaker. Why? This Erlenmeyer can be used to mix. The upper part is made like this, so you can shake, so you can mix by using an Erlenmeyer. But for beaker, later you will need a stirring rod to mix the salt and the water. Okay, so now 5 grams. Since I put the salt into the beaker, it means I have to measure again the triple beam balance for the glass and the salt. Okay, I've already set into 0. It's already in balance. Okay, the beaker and the salt, it's bigger compared to that previous is only the salt. Why? Beaker has its own mass. We'll need 95 grams of water. If I add up, this one is 102 plus 1 gram, and I add with 95 grams of water, it will be 197.1 gram. Okay, so I have to slide the arm, measure it become 197.1. Okay, then I pour, add up, it will add up later. You can see it will slowly This grow. One is mortar and pestle. You might need this one if you want to grind something solid to become a powder. So you will need a mortar and a pestle. And this one is a petri dish. A petri dish biology lab to cultivate yeast or bacteria. And this one is an electric stove. It works with electricity. It can be used to heat some materials or anything. Sometimes if you want to heat a liquid, of course you have to put the liquid into the beaker. You cannot just heat there. You have to put the liquid into the beaker first and then heat up. And don't forget to turn on the electric stove first before you heat the liquid. I think that's all about our apparatus that we might use in laboratory. There's still more. You can find another one, and that will be your task today. Find at least another 5 laboratory apparatus that you might use in our laboratory, either in physics laboratory or biology laboratory. Thank you for watching and see you next time.